actively on really figuring out is the edge play. So my quick agenda, as I said, I'll try to, and then I'll highlight what should be the ideal architecture look like, and some key takeaways. So let's look at the application patterns. So here, I'm trying to lay out the way existing service networks or service topologies of different applications patterns are there. So here I'm trying to show both processing, data management, and networking. Cloud native apps are already well understood. That is the predominant trend now, moving away from monoliths. So if you look at cloud native apps, basically the new interface called touch that enabled the whole new way of writing apps, because now you have so many different UI from your mobile phones or tablets that you needed to take that front end and put it in a so-called cloud, and you can still keep your backend separately in the data center, and that enabled the cloud native apps. So it is very similar to existing content delivery and app delivery. So here you see that most of CDNs are either on the local or metro regions, distributed globally, but most of the data is still sitting in the centralized data centers. Now the second emerging app, which is about this whole term misnomer called AI, is really a machine learning or deep learning. So what happens here is that here, this new pattern is basically you keep sensing everything around, no matter what it is. It is a factory, it is a home, it is a building, it is your personal vitals. So these kind of apps, they keep sensing things. And then there is some functionality which starts thinking about what to do about it. And then some action will be required. For example, preemptive action to prevent bad things from happening. So that's what I think we heard Saurabh and Brian talking about, like predictive analytics and descriptive analytics and all those terms. But application pattern-wise, it is basically sensing, thinking, and acting. So that's the new pattern coming up. And then the third one is immersive media applications. So all the mixed reality, augmented reality, virtual reality, all these newer applications, if you see, they are very heavy on production side. Before it goes to distribution globally, the production of current media process is not really enabled to do the augmentation. So with these three architectures, let's see really, is it about latency or is it about something else or both? So to get these answers, Breen Erickson started doing very detailed prototypes and trying out those prototypes with a couple of industry players. So here, this is the example where we started working with GE Digital and Honeywell and other players in the industrial space. So if you see, this topology shows basically that decision-making process is distributed across the enterprise. Some decisions are made very fast at every individual machine or human level working in any factory or any shop floor or any warehouse. And when you go from the enterprise side, the decision frequency changes, like forecasting and reporting, that those decisions are made probably every quarter or every 6 months. So essentially what industry required was, or what we thought the bottom-up approach is that if we can automate all this decision making by applying any of this big data and AI/ML and those technologies, then that would be a requirement to put that compute very close to the edge. So if I want to meet a 10 hertz frequency and 100 millisecond latency, meaning that I have to take all the data from previous 100 millisecond, all the sensor or other tags, crunch those data, apply my AI inference or ML algorithm, and then take the action. So acting, sensing, thinking, and acting, whole cycle, if I have to do it in 100 milliseconds, then I would need compute at the edge. But when we really went to the industry and we talked to them and we started deploying this, the real problem surfaced. The real problem is basically that the CIO stands that I can get a compute and storage at the click of a button from a public cloud, but I can't get access networks at the click of a button. So the problem is that even before, so this is the top-down approach I was talking about. So when you think from the end user's problem, pain points, they would love to do this, but right now they have a much bigger problem to solve. And that was, barely they have a budget to maintain the Wi-Fi networks. And I learned from some of the startups that one of the startups is using a drone camera to do inventory tracking in a big, huge retailer's warehouse. And they have one of the top vendors Wi-Fi network. And still those simple sensing doesn't work. Simple camera, image processing doesn't work on that network. So even after deploying that CapEx, they're not able to get to anywhere. So the key message here is that it is not just about having an edge compute or a latency, but we have to look at connectivity and compute together and offering it as a service. So basically trying to bring benefits of the cloud network or cloud computing, not the technologies only of the cloud computing. Same thing happened, very similar. We started looking at the total, what are the other areas, verticals. So emerging application pattern of immersive media or AR, VR, MR. So there we started thinking that, hey, this 5G would be excellent. You would need for any augmentation and distribution. So we started working with Fox Sports to validate our hypothesis. And one of the operations VP of Fox Sports who manages all the live Fox production, Fox data center, and from there they give it to all the distribution like Dish Networks, Comcast, AT&T, all Time Warner, everybody. So now, once this 5G fiber gone, they realize that if you take out this media production requirement on the venue, then they can potentially cover a lot. And that metro level data center cannot be more than 30-40 miles in US, at least in this geography. So we are talking about, and even if you put a lot of optical switches in between, we are not talking about more than 15-20 milliseconds from microseconds. So it is not about the propagation delay or latency, it is about what is the application experience budget or part are also on the periphery. So that closed loop control or closed loop action orientation may require us to push some compute out there. But network latency itself won't solve it. Think about that, the 5G networks will bring down the network latency to less than 10 milliseconds. We proved it on the Fox trial. But if you have a Lambda, Amazon's Lambda architecture or any function as a service architecture, it takes 50 milliseconds to load. That is the best you get today in the industry. So if your compute itself takes 50 milliseconds to load, how would it help you bring down the latency of the transport or propagation delay? So what is the required architecture? This is our internal Ericsson thinking, and this is what we launched it as a 5G edge platform. So here, in the ideal world, we would like to have a unified way to order a slice of network with compute distributed, and where you distribute the compute should be dictated by the application flow with cloud. Because the efficiency is there, you cannot beat it. Once you consolidate the resources, the operational and capital efficiencies you get, you cannot distribute out those resources and still get the same efficiencies. So as we learned in the Fox wants transcoding and VR creation and augmentation of the content at the truck site, and that is hindering their flow. So they would like to put it in some metro data center, and they're willing to pay a lot more than what they've done on the public cloud because they have a need. So with that, I think